Yeah, I apologize to those who are tall. Okay, scooch in. There's a lot of us, I know, so let's fill in. Scooch! My goodness. Short people in front. Do what you got to do. Yeah, short people. That's right. This is a great place to be short. We have a lot of tall operators, and they've taped foam over the sharp corners here. Feel safer? So there you go. All right, ladies and gentlemen, I want to introduce you to the world's first superconducting cyclotron. This is it. This is what we invented. Well, Henry Blosser and a lot of helpers invented this, finished it in 1982. This is what put us on the map. This is why we are famous. 10-foot wide white cylinder. You know, I can't show you anything smashing. A, we shouldn't be in here, and B, you wouldn't be able to see it anyway. So, if you want to accelerate and smash things, nuclei come from the ion sources up into the center of this, so from the bottom, up into the center of this circle. You see those big copper pillars down there? Yep. Those are what we call resonators. They charge the center parts of the cyclotron up to 140,000 volts. That's what accelerates the nucleus. Then surrounding that accelerating area is the coil of superconducting wire. So that wire I showed you, 20 miles of it is wrapped around this thing. I know. And that generates a really powerful magnetic field, so that's what keeps the nuclei going in a circle. This red stripe on the side, that's the plane on which they actually travel. So that's where they would be. And then they spiral out faster and faster, and they come out this pipe right here at about 30,000 miles per second. Not bad. This is a video camera. You can't see nuclei. Good try. But there's a little fluorescent screen you can actually put in the way. And when nuclei hit it, it fluoresces, it glows. This shows the picture back to the control room so the operators can see, kinda, where the nuclei are. Are they in there? Are they off center? Where's the beam? That kind of stuff. Is it defocused? That's one thing you can do. So you can diagnose your beam. You can know something about it. So it's coming out of here going fast. These are all magnets, 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 a bunch of superconducting magnets. And they are diverting the nuclei, steering them down to the next cyclotron, which is down the other side of the wall down there. It looks just like this and is 4 feet wider. We're not going to go see it. It's the same thing. And that will get us up to about half the speed of light. And then on the other side of that wall, we smash. And of course, you can break the nucleus, you can make a lot of different kinds of isotopes. And once you've smashed, you actually have made so many different kinds. We need to go through the filter next and get rid of the stuff we don't want. And that's actually where I will take you next. But before we do that, I want to show you a few things about systems. This is our power cable for the cyclotron. We consume 3 megawatts here. That's equivalent to about 6,000 houses. We spend $1 million per year on power. That's your money again. Thanks. The pipes you're seeing everywhere are cooling. The copper ones are water. The silvery ones will be liquid nitrogen or liquid helium. We use 3,000 gallons of liquid nitrogen every week. But it's only 26 cents a gallon. It's fine. We make our own liquid helium because that's like 10 bucks a gallon. It's a lot more expensive. The thin wires you're seeing everywhere usually come from the control room telling this stuff what to do and getting information back. And the noise you hear in here, in most places, are vacuum pumps. There's no air, really, in this equipment. It's about 1/1000th of an atmospheric pressure inside our cyclotrons and the magnets. Everywhere the nuclei would go, it's under vacuum. Because if you shoot a nucleus through the air, it hits air and stops, and they wasted all your time. So there's no air, really, inside this equipment. Not bad. So those are the systems you'll see everywhere on this tour, really. You've already seen them several times. Good. Any questions? No. You're like, this is so, pedantic. Anyway, that's fine. I understand. It's really overwhelming. The first time I came here, I had a PhD in physics, and I was overwhelmed. So, it's okay. Let me go show you where we do the filtering. This way.